Sunset, the leading and most trusted name in the do-it-yourself information field, presents Sunset Video, a complete line of home improvement video cassettes, over 20 project areas. Subjects include wiring, plumbing, carpentry, decks, flooring, kitchens, home repair, tile, paneling, painting and wallpapering, skylights, bookshelves, furniture refinishing, cabinets, and more. And each tape comes complete with a 16 to 48-page booklet that provides you with additional helpful information, as well as a list of tools and materials you will need.
Practically anyone can stay comfortable practically anywhere with the right preparation, indoors or out. These young athletes insulate themselves against the northern winter so they can comfortably enjoy the activities the season provides. You can be warm or cool no matter where you are with proper insulation. These homes, for instance, long before they were built, heating was simply a matter of throwing a couple of extra logs on the fire, while cooling was simply a matter of opening a few windows and letting the wind blow through. But today, to enjoy these kinds of comforts, we have to rely on the mechanical efficiency of furnaces and air conditioners. But even the most efficient mechanical system requires energy, and energy costs money. So, whether you're paying to heat your home or to cool it, just remember the formula is always the same. The better your home is insulated, the lower your energy costs are going to be. Hi, Wayne. Thanks. I'm Kurt Burbick, and today we're going to show you the basics of insulation so that you can dramatically reduce these energy costs. Now, in our companion show to this, Weatherization, we demonstrate still more ways to stop these unwanted energy losses. Weatherization and insulation are meant to work together, and while each by itself will do a good job of keeping the energy where you want it inside your home, put them both together and you and your family can enjoy greater comfort on a much lower energy budget. And the beauty of both these things is that they make fairly easy do-it-yourself projects. Now let's join Avian Rogers and she'll tell you more about our show.
Insulation can be any number of products that add to your ability to restrict heat flow. What it doesn't affect is slow the natural process of heat escaping from a warm area into a cold one, or in the case of a hot climate, keeping the heat out. We'll show you how to use insulation of various types in various situations, starting with a project that will give you your fastest payback, the attic. We'll show you how to use fiberglass batting insulation to convert your attic to living space. We'll show you how to use it on your attic floor where you don't need to heat the attic itself. And a popular alternative to fiberglass bats is blown-in cellulose. We'll demonstrate the use of a rigid foam insulation on interior and exterior walls. And for a wind-up, we'll talk about ventilation and show you what you need to know to install a wind turbine. But before we get into all that, let's tackle the all-important subject, tools.
Insulating an attic space isn't all that complicated, especially when you have the right tools handy. You should have a 20-foot measuring tape, a utility knife, some kneeling planks, a circular saw, a staple gun, a reciprocating saw for roof work, a pole for poking insulation into the corners and tight spots, and a trouble light and an extension cord. This is a machine for blowing cellulose into the joist spaces. Its design makes it ideal for reaching those hard-to-get-at spots back under the eaves. Now, you're going to have to rent a machine like this at your local home center or hardware store. So make sure before you bring it home to check with the rental people about its operation. And check your operator's manual.
Now, the main problem with modern insulation materials is dust. So a mask and goggles are really a must.
You know, Avian, there's one more thing that's going to come in very, very handy.
What's that, Kurt?
It's this.
What does a bottle of vinegar have to do with insulation?
You know, Avian, I'm going to show you a little later.
Right, Kurt.
The first thing we're going to tackle up here is insulating this space as a part of an attic room conversion we're planning. Now, insulation alone won't make this a usable room, but the additional processes we'll need to do that we'll be covering in other shows. Our big problem right now is this, that some of these rafters just aren't deep enough to accept the fiberglass batting insulation we want to install. Also, you'll notice an incredible unevenness between these rafters that needs to be corrected so we can nail up drywall over the installed insulation. So that's why we're attaching, or scabbing on as it's called, these 2x4s to the existing rafters, furring them out, as it were, to create a space deep enough to accept our insulation, giving us a nailing surface for our vapor barrier that we'll be showing you later, and giving us a structure capable of supporting finished materials like drywall and paneling.
We've put up these reference lines, which are simply a couple of strings that we've stretched across the face of the rafters that come out the farthest. So this will ensure that our scabbed-on boards are installed evenly across each side of our roof line. So we'll have created a structure that not only accepts the full depth of our insulation, but also a flat and even surface that we can hang drywall on later. We can easily measure and position each necessary board for scabbing using these reference lines. We check it against the strings and then nail it securely into the existing rafter.
That should about get it. We've repeated the scabbing on process around the entire space that will eventually become our new room. Now let's take a look at what we need to do to get the air circulating to carry away the moisture that would otherwise build up between our new insulation and the roof itself.
Because we're installing our insulation practically right up against the roof itself, we want to provide at least adequate ventilation. Now, this waffle styrofoam type material is called FlexiVent or vent board, and it takes care of that quite well. Simply stick it up between the spaces and then attach it using a staple gun. Now, having made good provision for ventilation behind our batting, we're ready to go ahead and start installing our insulation.
You've probably heard the term R value in conjunction with insulation. The R stands for resistance to heat flow, and the higher the R value, the greater the insulating power. Now, because the requirements for R values can vary so greatly from area to area, to know what you'll need for your home, you should probably check that with your state energy commission, your local power company, or your home center or hardware store. What we've got here is R19, or 6.5-inch thick fiberglass insulation.
Now, when you're working with fiberglass bat insulation, you want to keep from breathing the little glass filaments that can fill the air. So wear a dust mask. To keep the particles out of your eyes, wear goggles. Now, to keep the material from irritating your skin, wear a long sleeve shirt and pants, and gloves are a must. Now, what I'm doing here is I'm measuring the length of the space, cutting the bat to fit, using a utility knife with a good sharp blade. Since we're doing a demonstration, I'm not wearing my mask right now, but it's important precaution to take. Now I'm going to stick the batting up into the space. Friction does a good job in holding this batting up there, but just to make sure that it stays up there, I'm going to attach it with a staple gun. And by pulling these paper tabs away from the body of the insulation itself across the face of the rafters, we can then staple using our staple gun. Now always be sure and install your fiberglass backing with the paper side facing the warm side of the house, and this will help act as a vapor barrier.
Since this old attic framing was installed so carelessly, we've had to cut several of our pieces of insulation to a special width to get a proper fit. Now you've got your regular paper flange for stapling on one side. To get it on both sides when you cut this special width, overcut it by 1 inch, then tuck the fiberglass in a little bit, and that'll give you a paper lip on both sides for stapling.
There are a couple ways to avoid compressing your insulation around wiring. Now, when dealing with new wiring, you have a chance to wire for energy efficiency right from the start. By notching along the face of the stud and then putting a protective cover plate over it, when you install your batting behind it, it won't compress. Now, when you're dealing with existing wiring, like this old knob and tube, if you stuffed your batting behind it, you would compress your batting quite a bit. Instead, take your utility knife and slit across the back without cutting your vapor barrier, and then fit your insulation around it.
In preparation for installing our vapor barrier, we need to poke holes in the paper face of all of this insulation we've installed. If we don't, there's the potential for moisture to get trapped between that paper face and the vapor barrier, and that'll eventually damage the insulation. We're going to put a vapor barrier over all this in order to prevent the accumulation of moisture between the batting and the underside of the roof where it could cause rotting. All this amounts to, really, is a painter's drop cloth, actually nothing more than 6mm visqueen, and we'll put that up along the face of the rafters and staple it in. As you're working with it, be careful not to puncture it and to get it as airtight as possible. Once we've gotten our vapor barrier in place, we've finished insulating the rafters of our attic. A lot of attics, like this area in ours, are completely unfinished. No ceilings, no floors, no insulation materials at all. So if you've decided not to develop your attic area into a living space, you're going to want to insulate the attic floor. And there's basically 2 ways of doing that. First, you can install fiberglass insulation, like we've been putting in our roof rafters. Or you can blow in cellulose insulation, and we'll be showing you that a little later. In either case, one of your concerns has to be about heat from the rooms below infiltrating up through this ceiling, around things like heater ducts, piping, or chimneys. And the way to deal with that kind of a problem is just to be real careful about installing the insulation in between the joist spaces around those kinds of protrusions.
If you're not going to convert your attic into living space, then you want to insulate your attic floor. So we're installing fiberglass bats in the floor joists above our main living area. Now, when we were insulating our rafters here, we said install the fiberglass with the paper side towards the warm part of the house. So in this case, that's underneath us. So here we're installing our fiberglass bats with the paper side down. Now here we've got two roll ends coming together. So we want to be sure and butt those ends up snugly against each other to seal up any gaps. You'd be amazed, even the smallest of gaps can lose heat. Here where we have this pipe coming through, we can take a scrap of fiberglass insulation and wrap it around, filling up any of those small gaps or cracks. Then we'll just run our bat right up alongside of it. There's no need to worry about covering up these junction boxes because they don't put out any heat. But don't compress or squeeze your insulation or you'll lose its insulating qualities. In the case of a recessed light fixture, though, leave about 3 inches so that air can circulate around the fixture and cool it. When you're insulating around a chimney, flue, heating duct, or other heat source, use an unfaced fiberglass batting. The material used for most vapor barriers is very flammable, so using an unfaced batting will eliminate that hazard. With the aid of this little stick, I can stuff this fiberglass back into this tight spot. After you've filled all your joist spaces and you still need a higher R value, you can do that by laying out another layer of fiberglass insulation across your joists. Now before you do that, puncture holes in your vapor barrier. Using your utility knife, you don't want to add any condensation buildup between the two layers. Now, since we've already taken care of our special considerations like the pipes and the small cracks, our main concern is butting up the fiberglass snugly, side by side, end to end.
Hey, Avian, about the vinegar. The tip is that if you put a little bit of vinegar in the rinse water after you've taken a shower or a bath, it'll practically eliminate all of that itching that you get when you work with fiberglass insulation. There, isn't that a great tip? Aren't you just itching to use it?
Not exactly, Kurt, but I'm tickled to know about it. Now, you've seen how to use fiberglass bat insulation in overhead rafters and floor joists. And these principles basically apply to anywhere that you'd want to use that method. And we mentioned earlier that there is another method to insulate the floor of an attic space that you don't want to pay to heat. To do that, you want to insulate the floor joist to keep heat from escaping from the room below. So we're going to use blown-in cellulose. Now, cellulose won't give you the same R factor per square inch as fiberglass batting, but the advantage is it's inexpensive, quick and easy to use, and it's great for getting back in some of those tight, hard-to-reach spots.
One of the big advantages to working with blow-in insulation is that you don't have to lug this equipment up to your attic. You can position your blower and your cellulose in any part of the house.
With blown-in cellulose, we'll fill these joist spaces past the top of the wood framing to get the total R value we want here. This is a dusty job, but it's not too unpleasant if you're wearing the right stuff, like a dust mask and safety goggles. The great thing about blowing in insulation is that you don't have to have all your stuff crammed into the attic while you do the job. One person can be down on another floor or even outside handling the equipment and the cellulose while the other blows it in. You can blow up to 100 feet away from our machine. Be sure that as you work back into the corners and around the E-vents that you don't fill them up or cover them over. Just going to straighten up here a bit. Then we want to show you another kind of insulation that will further help to improve the energy efficiency of your home. Now, one of the easiest ways to insulate an exterior masonry wall on the inside of your room, like for a basement, is to use rigid foam panels. Now, rigid foam does not have quite the moisture problems that other types of insulation can have. So the first thing you'll do is install 2x2 furring strips, 16 inches on center, using an adhesive to make your attachment. Then cut your rigid foam panels so that they fit between the spaces, using a friction fit to hold them into place. Then you will have created an insulated wall surface that you'll attach drywall or paneling to create your finished room.
Now, you can do the same thing on the outside of your building, of course. The difference is you'll need to dig some trenches to get the insulation into place. Dig a trench down about 2 feet deep all along the foundation area where you want to insulate, or deeper in cold weather areas if you have a deeper frost line. Then put your insulation foam boards right up against the concrete, and to keep the water from getting between that and the building, you'll want to install some galvanized sheet metal flashing over the top of the insulation. Then to hold the whole thing in place, push the earth back into the trench, backfilling the whole area. In any given day, in any house, 40 to 50 pounds of moisture can travel up through the ceiling into the attic area. Moisture that comes from washers and dryers and people taking baths and showers. And if the attic isn't properly ventilated, that moisture can get trapped up there, causing a lot of deterioration in the insulation and the wood framing. And if insulation gets damp, it begins to lose its R value. So let's take a look at what we have to do in our attic to get it properly ventilated. We need to let the air start flowing into the roof out here at the roof overhang, up between the rafters, above the insulation we installed, and out the top. We need to let it out as high as possible. Down here in the flat gabled end of the roof, right here would be one place, or in the case of a hip roof where all the roof faces are sloped, up here at the peak. Now, no matter where you let it out at the top, it's important that you get good air circulation from all sides of the roof. It's also important that you check each rafter space to make sure that this airflow pattern isn't interrupted by any wood blocking. If you find that, just drill a couple of holes to let the air flow through. There are several low-cost and simple devices you can buy to install in your roof to achieve this airflow pattern we've been talking about. For instance, at the roof overhang, you can install this interesting-looking little device. It's called a soffit ventilation plug, and it's got louvers and screened to allow the air to flow through, but to keep out the insects and the rain. The way you install this is to drill a 2.5-inch diameter hole in every rafter space all around the roof overhang of your house. Once the holes are drilled, then you can just pop these little devices in place, and that'll now allow the air to start flowing in at the low end of the roof. Once it comes up to the peak, there's several ways we can let the air out up there. For example, here's a sheet metal, louvered and screened ventilation piece, which can be installed in the flat gabled end of the roof to let the air out up high. Or if you need to let the air out up at the peak, you can do that by installing this continuous ridge vent piece. It's screened and it's sheet metal to let the air flow out, but to keep the rain from coming in the attic area. Now, this comes in 10-foot lengths, and if you put them together end to end, that'll allow you to vent the entire ridge of your house. One more item I'd like to show you, and it's a real gem. That's this wind turbine ventilator. You install it in your roof, and the wind grabs these vanes and starts it spinning. That encourages the air and the moisture in your attic to get carried out through the roof. It does such a good job, in fact, that we can't resist installing one in our attic roof.
To install the wind turbine, the first thing we did is find a good location. Obviously, we want it as close to the top of the roof as possible, and to be sure that we clear the rafters below, as they act as our support for our whole roof system. Next, we drill a starter hole and complete the cutting of our opening using the reciprocating saw. Next, we'll take our caulking gun and apply a generous amount of roofing cement taking all the necessary steps to ensure that our wind turbine is completely leak-proof. Since we don't have shingles here to contend with, we'll cover those aspects and other issues in our roofing show. Then we take the base, put it into position, and nail down using some roofing nails. Once that's installed, this fits neatly into place, attach it with screws, and we're all set.
Well, we've taken a little time out here to just kind of treat ourselves because
we've just completed one of the two biggest steps we can take towards a more energy-efficient place to live. And
energy efficiency isn't the only reason for insulating, by the way. Air conditioning and general comfort season to season count easily just as much as the brute economics of heating. And in some parts of the country, it'll count even more.
There are other pluses worth mentioning. Pluses like local, state, and federal tax credits you may qualify for, or low-interest, no-interest home improvement loans.
These programs are going to make it easier for you to pay for your insulation project, and that helps too. So any way you figure it, insulating your home properly is going to save you money. And not just in the long run, but season to season from the very time you complete your first project. Add a few weatherization measures to your insulation efforts, and you're really going to save on your fuel bills. What you're seeing is a house as it appears to the eye of an infrared camera. See those vivid colors? They indicate warm spots, places where the heat is moving outward and therefore being lost. This front entryway is particularly bad. Not only is there a serious problem between the bottom of the door and the threshold, there are gaps all around between the door and the frame and between the frame and the wall. These windows, especially the one on the end there, are in desperate need of help if they're to hold any heat in the house at all. Look at this heat loser. There's a crack in the foundation here that will probably have to be stuffed with some kind of filler like fiberglass or sponge and then caulked to stop this energy leak. Hi, I'm Kurt Burbick. Well, I guess all of these problems look like a lot of work, right? Well, it's really no sweat. What you're seeing here is a lot of holes and cracks in the building, and all you have to do is plug them with a process known as weatherization. And with the weatherization techniques we're going to show you in today's show, you can solve a lot of your energy problems almost as quickly as I can describe them. And that's the beauty of weatherization. It's really so simple and so inexpensive, yet the paybacks are so immediate. It's almost more effective than insulation in many cases. And with the two of them together, you can reduce a lot of your energy costs and keep them down to a bare minimum. Now, my point here is not that weatherization is better than insulation or vice versa. My point is that you need them both. And you need them both for a very good reason, and that is that they each attack a different problem in the building. Insulation really addresses the problem of heat loss in a building through the transfer of thermal energy through materials, or called conductive loss. Weatherization, on the other hand, addresses the problem of the heat loss in the building due to infiltration, or the movement of air in and out of the building through all the many holes and cracks.
Besides the losses that Kurt just pointed out, there are other losses. Losses that you can feel or actually see from the inside of the house better than the outside. See, houses actually leak. You can feel these leaks in the form of drafts, or maybe it's not going to hit home till it comes time to paying the bills. Insulation does for your house what a sweater will do for your body. It slows the radiation of heat away from your skin. Now, if you go outside and there's a stiff breeze, you probably want something a little more, like a scarf or a hat, something to pull over your ears. That's what weatherization is all about. So let's go see what it's going to take to do the job right.
There really isn't all that much to weatherizing a house. Basically, it's turning your heat losers into heat keepers.
You mean we should use materials designed to fill the gaps and the cracks to keep the heat in, right?
Exactly.
What tools do you think we'll need?
Well, to weatherize a house, nothing very special. It's pretty much basic carpentry tools. A hammer, a screwdriver, a razor blade, utility knife. And because we're going to be replacing the threshold on our front door, we've got a couple of power tools here. A jigsaw, and this is a power circular saw. Now, one really nice power tool that gets a lot of use in building is this 3/8" electrical drill. For example, if you install this screwdriver head insert into the drill, What you've got now is an electric screwdriver gun, which is very good, for example, if you're doing wood screw installation. Now, most of the weatherizing projects you'll get into in your house can be done from the inside. There is an occasional thing you'll need to do from the outside, like installing storm windows, and for that you'll need a ladder, and particularly if you've got a two-story house. Now, here we have a rather large array of some basically inexpensive and very easy to use weather stripping and weatherizing materials. All right, here's some fiberglass insulation from our attic insulation project, and we're going to use it in weatherization by taking this and stuffing it into the big crack in the foundation on the outside of the house to fill that crack up before we then seal the outside of the crack with this caulking material. And the way you apply that caulk is in the tubes, and you use a caulking gun so that when you pull the trigger, it forces the caulking material out the end of the tube. Now, here's an interesting product called a weather insulation kit. And it's installed from the inside of your house, and you cut with a pair of scissors this plasticky material. You tape it onto the window frame with this roll of tape that comes in that package, and then with a hair blower you heat that material up so it becomes taut over the window and flat. Now, there's a whole array of different kinds of weather stripping materials. Here, for example, is sticky back self-adhesive sponge strip, and you can peel this tape off the back and take this sponge strip, and it'll stick to almost any material you want it to stick to. So you can patch, again, cracks around doors and windows. Here's a vinyl tubing, comes in a roll, can be cut with a regular pair of house scissors. Again, this fits in cracks around windows and doors to seal up that little seam where hot air can leak out of the house. One of the nicest materials to use for this purpose is a more recent development. It's a V-strip, and it'll fill up that little crack so that the air can't get out. And we'll be demonstrating how to use this later at the front door. Now, at the bottom of every door, you always have a problem in a house where there's a large crack between the bottom of the front door, or any door, and the threshold of the door. By the way, we're going to be installing this oak threshold in our front door of this house. So as you can see, most of these materials are extremely easy to use. They cost very little, and the payback on them is really quite good. So you can see that weatherizing is a project that's easy and inexpensive to do.
Well, I suppose these two doors are going to be a real pain to deal with, huh?
No, not at all. As a matter of fact, there's some built-in advantages to having two doors.
Like what?
Well, this vestibule creates a dead air space, so that when you come out of the house, if you close the first door before you open the second one, you don't get a lot of heat loss.
Well, so what about weather stripping these two doors? Should we do both?
Well, you don't have to, but I would if I were you. Remember how clearly that infrared thermograph showed a lot of heat loss here at these doors. So by weather stripping both of them, we'll create a real tight front door entryway.
So where do you want to start?
Well, in general, you might check things like the door hinges. You don't want to have loose hinges if you're going to be installing weather stripping. But for the most part, it would be best to start at the bottom, down at the threshold, where you encounter usually the largest gap.
Boy, look at the dips and the cracks in this thing. It's
Yeah.
completely worn out. Let's check the gap under the door here. Now, we can see it if we take this chisel and stick it underneath. It goes almost in completely. So we're definitely going to need to replace the threshold. Now, it looks like it's wedged in position here. So if we take a saw and cut across the middle of it, then we can just pry it up in two places, and that should be pretty simple. Before I cut the threshold, I set the blade on my saw, so I only cut through the threshold and not into the floor. Well, it looks like this is going to pop up real easily. Got this flat bar. This comes right up. What a mess. And this one comes right up. Just getting this last bit of debris out of here.
All right, here's a stock piece of oak threshold that you can buy at any lumber yard. And as you can see, removing this threshold takes a little bit of care. You want to make sure you don't chip out these trim pieces on either side when you're doing that.
All I need to do is measure the opening now to cut this threshold to length. Since we're not taking the doorstop off, I'll need to notch around on both sides. Now that we've cut and notched our threshold, we're just about ready to put it in. But before we do that, we want to make sure that we caulk between the threshold and the floor itself. This is going to seal up any air infiltration from getting in there. Now, you're probably familiar with caulking tubes like this that go in a caulking gun. There are cans of caulk now available under pressure that only require you to depress the end of the nozzle to release the caulking material. Okay, now I'm going to attach the threshold with some 8-penny finish nails. Finish nails don't have heads on them, so once they're in place, you won't be able to see the heads. Now, before I do that, I'm going to want to drill in 3 or 4 places along the threshold. Since the threshold is made out of oak, it's hard wood, and it could split by the nailing or it could bend the nails. So I've got my drill bit the size a little bit less than the shank of this nail. Now that I've got the nails in position, I take this nail set and drive the nails a little bit below the surface of the wood. Then I'll come back and fill those little holes with wood putty, stain the threshold, and put some finish on to protect it.
Yeah, it's looking good. I guess we're about ready to start the weather stripping of the door now.
Looks like it. Okay, now that we've got the threshold installed, we want to seal up the gap between the top of the threshold and the bottom of the door. And I've got this rubberized door seal that is very cheap and easy to install. Now, I know that the surface here is clean and dry, so all I need to do now is pull the paper tape off. I've already cut and measured it to length. Then just stick it on. I'm sticking it on so I've got a little bit of flex at the bottom of the door.
Well, weather stripping a door is an extremely easy thing to do because of these new products that are out. This is V-shaped plastic. It's a self-adhesive, sticky-backed piece of plastic that you lay up in the seam along the door around all 3 sides so that any cracks that are around the door where infiltration can happen and there can be heat loss that occurs because of that can be filled up with this little piece of plastic when the door is shut. Now, the way you do this is just to take the paper off at the top, bring it down a little bit, and fit the plastic up there at the top of the door, and it'll stick right to the wood frame. And then as you bring the plastic down, you can simultaneously pull this paper strip off. Now, if you get it out of adjustment, that's not a problem because this product is made so that you can pull it up and re-stick it down. So you go all the way down the door with it to the bottom. Real simple stuff to work with. And down at the bottom, before you take the paper all the way off, get a measure where you want to cut it, bring it right down here and mark it with your finger. And with a pair of scissors, you can just snip that off. Then you can pull the rest of the paper away, run that down there, and it's in place. Now the process is to take the plastic and fold it back so the edge of it will now protrude into the space a little bit, like this. And you go from the top to the bottom again, making that V-shaped plastic with the bottom of the V shape protruding inward toward the house. And again, you take it all the way to the bottom. All right, now, you need to run it along the top and down this side to weather strip around the door here. But in our case, the door is fitting a little bit tight at the top. And if we put that piece of V-shaped plastic in there without taking some wood off the top, when we shut the door, the weather stripping would be kind of pulled away. So I'm going to get a tool and scrape the top of the door to take care of that. It's a fairly easy job, and the only complicated part comes in if your door happens to stick along the hinge side of the door. Then you're going to have to take the door off its hinges to do this particular job. That looks pretty good. I'll just clean it up here with this sanding block, and I think that'll probably be enough. Yeah, that looks fine. Okay, great. I've finished scraping off the top of the door. I've completed applying this V-shaped plastic all around 3 sides. Avian's installed the oak threshold and applied the vinyl threshold weather stripping. So this door is completely weather stripped now.
Hey, this looks pretty good. How's
Yeah.
the job coming?
Okay, all we have to do to complete the weatherization on this door is to apply the caulk to these cracks around the trim.
Well, I'll go get the caulking supplies.
Okay. There are a couple of things to talk about with caulking. It's a gooey material intended to fill the cracks in the building to stop air infiltration and moisture infiltration. So when you're about to apply caulking to a crack in a building, check it to see that there's no moisture inside the wall, because that caulking, once it's set up, will trap the moisture in the wall. Now, after about 2 hours, you can paint it. So if you're planning a paint job in your house, it's really important to do a thorough caulking job before you do that paint job. And also, don't apply any caulk in temperatures below 40 degrees Fahrenheit. It's a really very durable material. It'll last up to 20 years without cracking. Some people will need a little practice to be able to draw a good even bead of caulk. But you'll be aided in this by drawing that bead continuously rather than in a stop and start fashion. Now, the caulk actually needs to get inside the crack. So if the bead that you've drawn is on the surface of the wall, you'll need to take a putty knife to smooth that out. Now, the trick here is that the caulking gun you're using, or the pressurized can that Avian's using, could be held at just such an angle so that when the caulk comes out the end of the tube, it's forced immediately into the crack as you draw the bead.
Okay, so let's take a closer look at how to weather strip these double hung windows. We're using this plastic V-strip type weather stripping. It comes flat, so you crease it down the middle into a V shape. It's got a self-adhesive backing, so it's very easy to stick into position. Now, one thing you want to make sure of before you place it, that your surfaces are dry and clean, free of moisture. And when you stick it in place, the point side of the V goes to the inside of the house. Now, as far as measuring goes, it's real easy. You want to slide it up where you're going to want to go and just run it down with the paper backing still on it. Okay, now I know where I want to cut it. Then I just snip it with a pair of scissors. I could even do it with a pair of fingernail scissors. And I need to get the rest of the V in here. Pull the paper tape off the back and slide it up. Now this is going up as far as the window will sit when it's in a closed position. Okay, that should do it. Now you do the same process for the top, bottom, the other sides. One point to be made here is this seam between the bottom and the top window. The tape goes on the inside of the bottom window with the point down towards the sill.
Well, Avian's showing you how to take care of the inside of the house. Now I'm going to show you how to take care of the outside. Well, I'm popping off this old piece of window trim here to show you that this thick piece in between these old double-hung window systems is not a vertical structural member, it's hollow. It's a place where these counterweights and ropes ride that help make these double-hung windows operate properly. And probably if you have an older home with double-hung windows, you'll have some windows that aren't working right. That is, you know, when you lift them up and let go of them and they crash back down without staying in place. And that's because these ropes get broken inside here. And that's easy to fix, and you don't have to pop off that window trim to do it like I've done here, but we'll be showing you how to do that in another program. What I want to show you here is that this is hollow, and that means that there's only 2 pieces of wood that separate the warm air on the inside of the house and the cold air on the outside. And that's the window trim around here that you see from the inside, and this piece of window trim out here. So you can see if there's a crack between the window frame and either one of these pieces of window trim, then you're going to have a direct route for the warm air to escape out of the house. So I'm going to tack this back into place and get into caulking up these cracks.
So when we did our infrared thermograph, it really gave us a chance to study our heat losses. We saw that a lot of little problems can add up to one big heat drain.
That's right. And in this three-dimensional perspective sketch of a two-story wood frame building with a basement, much like the house we're working with here, it gives us a chance to show some of the areas where you need to watch for heat loss. And from our thermograph, you remember any of the window glass really glowed quite heavily with red, showing that you get a lot of heat loss through the panes of glass themselves. Now, there are leaks that can be filled around any kind of door trim, let's say at the top of a door or down the side trim of a door, and certainly at the base of a door where you get that gap between the bottom of the door and a threshold, you'll get a lot of heat loss. Another typical thing to look for is where pipes penetrate the wall of a house. Let's say where this water pipe is right here in the foundation. Now, on the back of our house, we have a very big crack in the foundation that we're going to have to fill because in our thermograph, we saw we got a lot of heat loss at that place. So you can see any place where you get a change in materials. For example, if this chimney were a brick chimney and this were a stucco-walled house, you would get a crack along there in almost every instance of those two materials coming together, and that would be a place that you'd have to spend some time doing some special sealing work to make that so it wouldn't lose heat there. So I think you get some sense that probably half the heat loss that happens in a house is not because you haven't insulated properly, but probably because you haven't taken time to fill the cracks and the draft places properly.
Hi, I'm almost done here.
Hi, so what you up to?
Well, you know how you and I were talking about setback the other day?
Right.
About turning the thermostat down at night and during the day when the house isn't occupied? Well, it sounded like a really good idea, but I wasn't sure I wanted to be messing around with the thermostat every time I turned around. But this one here is programmable.
Oh, that's great. Did you turn the electricity off?
I shut it off downstairs at the furnace.
Good. It's perfectly safe to work with these with the electricity on because basically it's a low voltage wiring system. But just for your own peace of mind, it's not a bad idea to turn it off. Well, it looks like a pretty easy installation.
Yeah, it's really been a piece of cake. All I do is take the wires coming out of the wall, I pop the old one off, and the wires correspond by color to this mounting plate, and then I mount it on the wall by these screws right here. Then the actual thermostat goes on top of that, and a couple of screws that attach it to the mounting plate itself. And then this cover plate goes on top of the whole unit. So I program it once, and then I don't have to mess around with it 2 or 3 times a day just to save a few dollars.
Oh, that sounds like a great idea. And I'll bet you'll save a little money, too.
Yeah, I think it'll be a lot more comfortable around here this winter, too.
All right, here's a place where setback or adjustment will really pay off, and that's at your hot water heater. Now, household hot water temperature needs are about 110 degrees. And what you'll find is most hot water heater thermostats are set up on high so that your hot water heater is having to really work too hard for what you need. So experiment a little bit and turn this down to normal and see if that doesn't do the job in terms of your tap temperature. Now, by the way, here's a place where you're going to get some immediate paybacks on this. Another thing you can do to save some money is to install an insulation blanket around your hot water heater like Avian's done. Now, this is a very inexpensive and very simple device to work with. It's just a piece of insulation wrapped in plastic. It gets taped around the hot water heater. A couple of safety points here. First of all, on a gas hot water heater, you want to make sure that the insulation blanket isn't too close to the floor so that the air that needs to feed the pilot light doesn't get cut off. Up at the top, we need to discuss another safety issue, and again, it's with gas hot water heaters. And you'll know yours is a gas hot water heater, by the way, if it has a duct like this one at the top. The issue here is that this duct gets very, very hot, so you want to be careful not to tape the insulation blanket too close to it. All right, now, since we have set the temperature down to 110 degrees, you may feel there's an appliance in your house that needs warmer water than that. So you can install this booster heater on the hot water pipe just in front of that appliance, so now that appliance will get the warm water that it needs. Just a little something else about energy efficiency then in terms of your furnace. If you will get it adjusted and tuned prior to the winter heating season, it'll be a real cheap way to save money on your heating bills. Now, you'll need a professional to help you with that, but the do-it-yourselfer can get involved here by checking the furnace ducts, and where you've got a joint in the duct that hot air may escape, you can take some duct tape, silverback duct tape, and tape those joints so you won't lose that hot air at these various points in your duct system, and again, you'll get a money payback on this one.
I got this electrical insulation kit at the hardware store. See, when you install an electrical box on an exterior wall, it can be really difficult to insulate from behind. So this is going to restrict any kind of air infiltration. And I just pop these things out, put this foam pad over, and then just put my plate back on. And then it comes with these two plastic plugs that go in the outlet when you're not using it. You can also get switch plate covers for them, and it's really cheap and easy.
This is one of the newest and most popular alternatives to traditional storm windows. It's called window film. It's a clear, thin, remarkably strong plastic you apply to your windows from the inside. You buy this film package in this insulator kit. You stick this double-sided tape to your clean window frame. Then unfold the plastic, cut it to fit, and then, starting at the top of the window, press it firmly into the tape as you work your way down the frame, keeping it as tight as possible as you go. Once it's up, you're ready for your blow dryer. This shrinks the plastic, keeping it free of ripples and literally as clear as glass. The advantage to using window film is that it's easy to install, and it fights both conductive heat losses and infiltration. And because it's on the inside, it really cuts down on window frost. All right, you can remember from our infrared thermograph what a big heat loser this foundation crack was. And even if you didn't have a special camera, you wouldn't have any trouble figuring that out. Look at the size of that opening. Now what I'm doing here is I'm just finishing up stuffing in this fiberglass insulation into the crack. By the way, don't use fiberglass without wearing your gloves. What you want to do is back up the caulking so you don't have to fill the whole crack with caulking. And that's what the fiberglass is. It's just a backing material. And you just stuff it in there and pack it in good and tight. All right, I'm just finishing up with the last little part of this bead down here at the bottom of the crack. And a trick you should remember when using a caulking gun is when you're done and you pull the gun away, to release this trigger at the back so the pressure doesn't continue to drive the caulk out the end of the tube and cause a mess. All right, now that we've got this all sealed up, we're not going to lose any more heat here. We're all done with this one. If we all followed Avian's example, and in addition to insulating our attic and roof spaces, we tightened up our home with a good weatherization program, we'd cut down or eliminate big heating bills. Oh, by the way, before I go, I'd like to show you something. Remember how this door looked before Avian worked on it? See the even coloration? There are no temperature differences here to speak of, and that means no leaks. And check out this window. Doesn't it look tight? No excess energy leakage here. Even this gaping hole has been effectively plugged, and all with just a handful of fiberglass and a little caulk. Well, as usual, the little things add up to big things, and as you can see, that's certainly been true of weatherization. So I hope you can join us again next time for the next in our series of easy and inexpensive projects so that you can do it yourself. I'm Kurt Burbick, and thanks for joining us.
Sunset Home Improvement videos are specifically designed to work with Sunset Books, the most extensive library of do-it-yourself project information, with over 80 titles in home improvement and repair, decorating, and outdoor building. Sunset Books provides you with planning and design information, project plans, examples of completed projects, and detailed step-by-step instructions that were thoroughly tested by Sunset's experienced staff of building writers and editors. Sunset Books and Sunset Video together will give you the project ideas and building know-how you need to successfully complete your projects.